Hey, what's up, seventh grade? All right, so without further ado, let's science. A little bit of chemistry humor here. Um, we've got some sodium and some neon periodic table. That was sodium funny. I slapped my neon. That one. Yeah, chemistry humor. What are you gonna do? All right. Away we go. All right, so let's talk types of experiments. This is making good science. You've got the first type that we're going to talk about is the control method. This is when you have a neutral version of the independent variable that's present to compare your results to. Okay, which means that like a neutral version of the IV is like one that does not change, right? Because remember we were talking about the independent variable being the one that you're in charge of, you're in control of, you can alter it. A neutral version would obviously be one that is not going to change. Okay, so let's go ahead and go with this example. So in this experiment, the independent variable would be type of liquid a chicken bone is soaked in. Okay, so I'm going to do vinegar, I'm going to do orange juice, and my control is going to be water. Okay, so control method. So basically what happens then is I know nothing's going to happen when I put my chicken bone in water, right? That is my neutral version of the independent variable. I will then compare the results from the chicken bone in the vinegar, chicken bones in the orange juice, to the neutral version, the one in the water. That's how I can tell what changes occurred. All right, the second one is going to be comparison method. So there's no neutral version of the independent variable, basically that's present to compare it to. So basically you're just comparing like, I got this result and I got this result and I'm comparing the two. How's it look, right? So let's go ahead and do this experiment. My independent variable is just going to be the surface a car races on, and I'm going to do tinfoil and I'm going to do carpet. Okay. Basically, what I'm going to do is I'm going to run the car on the carpet and say, okay, it took this amount of time. Then I'm going to run it on the tinfoil, and okay, it took this amount of time. Compare the two. Boom, Bob's your uncle, right? Okay. So comparison experiment. You're just comparing one outcome to the other outcome. This is primarily the most, predominantly the most experiments that we do in middle school science are going to be generally a comparison method experiment. All right, replication. So the purpose of this is you repeat your experiment a few times to see if your test was just a fluke or if it really happens that way. Okay, so like if you do an experiment twice, how do you know, and get two different results, how do you know which one is correct, right? They're completely different. So 3 to 5 is usually a good number. Try to do odd numbers. All right. So again, if you replicated the experiment 4 times, you got 4 of this and 4 of this. How do you know what the correct outcome is going to be, right? Okay. So an outlier. This is a very different result from all of the replicates. Okay. You did everything right, but still got a weird result. Let me reiterate that. Okay. So like an outlier is not a mistake. Okay, so it's not an error. It's just you've done everything right, but for some reason, you just got this really bizarre outcome, right? But it is not an error. Okay, so an outlier is not an error. Keep that in mind. That's important. Like I said, outliers are not errors. You have to said it like 12 times, so keep that in your head. All right, testing yourself. Don't do it. It's really, really hard to be objective because as the researcher, you sort of know kind of what your hypothesis is and what your sort of outcome you're kind of going for, right? You are going to be biased. It's really hard to tell if you're manipulating the data. So when you're experimenting with people, make sure you have their consent. Okay, you cannot do an experiment without their permission. Make sure they know what the risks are. They need to be told of all the potential dangers in your experiment. And they can leave the experiment whenever they wish. If the participant feels uncomfortable for any reason, they can end the experiment right then. No questions asked. As a researcher, you cannot put them in unnecessary danger. So when you're experimenting with animals, only experiment when there is no other alternative. So do you have to use animals in your experiment, or can you get a similar outcome by not having to use animals? Also must only use the minimum number of animals necessary. So if you only need 3, you do not use 6 or do not use 7. Okay, only use the minimum number of animals that are necessary. You refine the experiment to minimize the impact on the animal. Okay, so like let's say you can do your experiment in 1 day, rather than, so you do not keep the animal for 4 days when you can do the experiment in one. You minimize the impact on the animal. And that's it. Good science, away we go. And we will see you in class. Thanks.